is being reduced. So many bad things are happening.
All right, Lance, get this power supply built for you, buddy.
I list it because I believe in you, and I believe when you hear about the facts, you'll want to take action. You know, I barely plugged today.
Had to, you know, change from that relay right there to this big humping 100 amp contactor relay.
We've got the biggest, best, cleanest.
Listen how loud this joker is, man. This thing's like a hammer.
That is expensive because it goes through the process of having any mercury removed. So you can get fish all day that's great and tastes really good, but you're going to get a lot of mercury in it that builds up. A lot of estimates are Japanese the longest lived people in the world is any major group. But then their brains also get eaten by mercury.
Thing hammers so much.
In the fish, they think they probably lived 130.
Watch my wire strippers move.
So again, we have the very, very best, and I want to show TV viewers. I'm going to take one of these. Look at the size of that baby. I mean, that is pure, clean fish oil that goes through the process of removing the mercury without boiling. Because when you boil it, it just fries it. So if you want your absolute complete,
it's a powerful contactor,
fish
man.
Oil,
all right, brother, getting everything wired up. Got the meter wired up there.
33% off, and that's as low as we can go.
Got this big honking, oversized 10 gauge wire here for the 110s.
Ultimate fish oil back in stock.
All right, buddy, on to the next.
I asked to meet
all right, brother.
From,
got the two supplies wired up.
That's what I did do. I don't know why I did it, but I just did it. But after that, I got to ask God to come back.
We'll get these bad boys mounted in.
Listen, you know, because I know I
and hopefully we won't have to take them back out for any reason.
And flying all over the place.
And it is a tight squeeze.
I haven't even done half of what I can do.
That's for sure.
And so I viewed it differently. So I know a lot of people.
All right, man, this thing's coming on along here.
I said I'm not ready to.
Got all the two 110 wires going to the relay there.
Have kids, etc., and how much.
Got them hanging out here for the.
They did give me some very interesting things.
Got them hanging out here for the wires on the back, which I'll be doing that very last, because
another Google
that right there will definitely put. I'll have to place it somewhere. You know, everything's kind of a mess over here right now. I got to clean up after I get done with this supply, man. I've been doing a lot of work here the last week or so. All right, buddy. We'll be back.
And I'm doing
seasonal distress symptoms, including promoting.
All right, brother. I got both the supplies mounted here.
Eye comfort and respiratory function.
I already got the
1960s, researchers in France
wire ran relay, everything. Just got done making your two common mode chokes, which I now have blisters on my hands. This right here is actually a number 10 gauge solid copper. We got these two common mode chokes I'm going to be doing. I could have probably got away with a one, but the reason I am using two is for current capabilities, and of course the extra will not hurt to cancel out some of the common mode noise, and I just use that for reference. Oh yeah. So alright, man, I'm going to switch this thing around and get these installed and get the power wires here installed and get it bolted up, man, and then I got to figure out what I'm going to do about the fans. So we'll figure it out. I'm either going to use this right here and run off the 50 volt output to power your two fans, which you don't really need, but still, or I'm going to try to put that in there, a little 12 volt supply. All I need is about 2 amps. All right, we'll be back. Listening to InfoWars. We'll see you. All right, brother. Got the power supply pretty much finished. I still got to put the 12 volt supply in there for the fans. I wish I had some very low power 50 volt fans, but I do not. The ones I do have are pretty powerful. Let me flip on the supply here. This is a new meter. I'm still learning how to use it. Alright, so we're sitting right there at 51.6 volts. which is exactly where we're supposed to be. So these supplies are, let's see, the out. Sorry about that, battery died in the camera. But anyway, these are right there about 51.4 volts, so that's perfect, man. They were both sitting right there at 51.6. So we made sure all these wires are identical in length. Oh, this thing's pretty big, man. This case is pretty big, so I kind of gotta stand up just to show it all. Pretty straightforward. Just got both of these current shared, paralleled. Got two common mode chokes, just to help keep, for one thing, keep the RF from the amplifier coming back into the supplies, and also helping with that switching frequency. Help alleviate a little bit of that noise. There still may be some noise down close to the lower ham bands, which I don't believe you'll be even running this anywhere near there anyway, so you'll be fine with that. Probably have to add another filter in there if somebody was going to be running it down on 80 meters, 160, 80, 75 meters probably, but you're good for that, man. So everything went together real good. Got the big 100 amp contactor in there. Everything's pretty good to overkill, man. Now here's your amperage meter right here. Now the way the amperage meter is going to work, of course, is you're going to have a plug, which I still need to make. A plug that's going to plug into here, okay? And then that's going to plug into the back of your amp. So I'll make sure to make that a decent amount of length. So anyway, I'm going to drop this supply in here for the fans, which you really don't need the fans. This thing, I see the fans are sucking from this area, okay? I got enough space right there for the fans to get air, and they're blowing through the supply, coming out the back, and they'll be coming out the ports right here. So really, the fans on top are just going to help that flow. You know, they're not going to be actually cooling anything inside here, just going to be helping the flow. So they're not going to need to be fast fans or anything like that. Thought about using this step down converter, but the problem is it only takes a maximum, I think, of 32 volts. I'd have to put some current limiting resistors before it. Instead of messing with all that, I'm just going to drop in a 2 amp supply here for the fans on top, and be very easily wired to the switch up here. And then think about this switch right here. The relay is doing all the work for the 220N. The only reason I use that switch right there is there are two pre-drilled holes right here in the front for these type of switches. This is actually called the old school 300 to 350 amp supply, which is the biggest case. I'm talking about the case from Mr. Anthony up there at Fat Boy ICA. And this is the cases they used to use for the iron core transformers. So you'd sit here and throw you know, three, sometimes you could pretty much, you could probably fit about 3 to 4 100 amp transformers. You might even be able to fit 5, but you would basically just lay the transformers this direction right here and put all your diodes that direction in your caps. So this is about the longest case they sell. So it worked out pretty good, man. It wasn't as a tight squeeze as I thought it was going to be. If I didn't have that meter right there, didn't have that amperage meter, you could probably fit, well, I know for sure you could fit 3 of these in this case. Be pretty tough to fit it without. You may be able to fit 3 without it. You could slide this to the side right here. Let's see here. You'd slide this to the side. Slide this right here. You'd get you a meter that's a little bit thinner up here at the top, maybe like a voltmeter or something like that. You slide this closer this way. You may be able to fit 1 more right here, fit the other one right here and then put all this stuff right here in the middle of that, you probably fit 3. Probably fit 3. I don't know why you need 3 other than if you're going to be running a 6 LDMOS. But anyway, let me quit blabbing around. I gotta get the fans done for you and get the top put on this, man. This is a beautiful candy painted candy apple green. A little bit of metal flake, actually a lot of metal flake. You can't hardly see it probably in the camera. These paint jobs do no justice in these cameras. When you see them in real life, it's a total different world. Total different world. Appreciate it, Lance. I know I had to go through a lot with this thing, man. I had actually was going, let me mention this real quick before I get off here. I was actually going to be going with a filter system to where I was going to be using about 6 separate filters. And mainly that was to handle current, okay? And this is what I did have in there actually. Is I was rolling with these, and if you see how small this wire is, I was basically having to roll with 6 of these, okay, just to make me feel better to handle the current. And then I had a little issue with space, so I took them out, and I just used double-sided sticky tape so I didn't have any extra holes. But I took them out, and I went with this right here. This right here, I think it's going to be a lot better. It's a lot better space-wise. This is a good thick 10 gauge solid copper on these common mode chokes. Okay, so that worked out a lot better. Also, I had rolled with these relays right here, which aren't very cheap, and embarrassing enough, these relays would switch off. Okay, basically the common was already touching the normally closed, if that's saying that properly. So basically when you gave it power, it let loose. See what I'm saying? So the relay became open at that point. Now of course I didn't need that, and that's just not thinking ahead of time. I should have checked that before. So I went ahead and went with this, and this has both of those in it, but the 2 on the side are normally open until you hook the power to it. And you see that big clanker going down. I first seen these relays in a BBI video. Mr. Luke Miller, the BBI, built a 300 amp supply. I'm sure a lot of you probably saw that video quite a few years ago. That's the first time I had seen these relays, and actually a good buddy of mine, I'm trying to remember who it was now. What was his call? Dang it, well he sent me 2 of these relays and I liked them. I really did like them. So I went and picked up 2 more, and I mean, you can't beat it. You can't beat these relays, man. These relays will keep actuating probably to the end of time, or till the zombies roam the land or something. But anyway, let me get off here and quit blabbing my mouth. The OGK with this big, huge cap picking project. Quad LDMOS on this cap picking end. Is it gonna work? I hope so. We'll see you. Bye-bye. Definitely got 114 amps of current for it to draw from. All right, brother. Well, here we go. All right. Right now, I'm just using my bench radio. Okay, it's a radio I've had to replace recently. So, the radio I had before did right there at 4 watts RMS. Okay, it only does. Let me turn this off real quick. It only does about 3 watts or so now, so it does a little bit less than what it did do. Had a little bit of reflect in there. Went ahead and fixed that just with the pass-through with this capacitor right here. So this right here is your pass-through, just flowing through the box, which does throw through the preamps relay down there at the bottom. That's a 5 watt slug in reverse. just to show you what we're going to be putting through the box right now. 5 watt slow, looking at the middle scale. A little bit less than a 1 watt dead key. Oh, yeah. A little bit over 3 watts. Oh, yeah. That's tiny power, y'all. Tiny, tiny, tiny power. Got the 5,000 watt slug. I hadn't used this slug in a while. And of course, the 1,000 right there, reading average. We're not going to get a heck of a lot of average out of it because we're only putting a watt into it. And this is a quad, of course, so this can take a little bit more drive. And I just want to do a quick show before I threw the attenuator board in for your radio. And another thing too is, you know, you got peak watts. You know, these things are a different animal than BJT transistors. I'm only putting about 18 or so peak watts through this, so we're probably going to be getting around 3,500 out of it. If I hook up a bench radio, or my Superstar right there does around 40 or 50 peak watts, you're going to get a lot more out of it. So, but I'm trying to be extra careful here, man. This is high dollar equipment. I need to get this thing up and out here to you, man. I know you've been hanging in there with me, brother, on this one. Big time. I mean, this has got to be one of the most patient customers I have ever witnessed. Ever. He has really hung in there with me. We've had a lot of R&D with this. Whew, it's been a little wild. A dang sure, the only thing I'm getting from this is knowledge. I definitely ain't got no profit. I promise you that. Knowledge is the only thing I have received from this project. Alright. Give me 1 second. I'm going to turn the power supply on. Be right back. Alrighty, we got the 50, about 51 volts. We got the box plugged in. I'll show a little bit more of the physical attributes to everything. Alright, this is your input reflect, and it is very nice and low. So that is a 5 watt slug, where you see the 1 watt, the 10, excuse me. That is a watt. In between that is a half. So we got just a little bit less than a half, which is perfectly fine. You know, we got this thing going through the whole combiner, 2-to-1 splitter and all that. Alrighty, we're going to be looking at the middle scale, same as the input meter there. This is PEP. So we're right there about 3,500 watts, like I said. Now, if you're looking at the RMS, we're not going to get a whole lot out right now. We're only putting about 1 watt dead key into it, which gives us right there about 400 watts. Swinging about 500. So that's not a whole lot, because we're not putting a whole lot into it right now. And I've noticed one thing too, man. Once you get these attenuators put on these things, a lot changes. I remember the first one I did, after I got the attenuator put on it, it just seemed like it swung a lot better on the RMS scale. And the only thing you're doing is lowering your signal. But I think with the very first one I did, the attenuator actually helped a little bit with the input match, because I mean, it's an unbalanced attenuator, and it's set for 50 ohms. And of course, I got the fans turned all the way down right here, which halves them off. We got one right there kind of trying to spin a little bit. Look at that. If I turn them on here, well, what am I thinking? Got the box off. So if I turn them on right here, boy, them things are blowing, son. Oh, unbelievable. All right. Don't laugh at me, Lance. We got blue fans in here for you, brother. I ain't gonna lie to you. I purchased 2 green fans for this joker and put them in, and they were non-LEDs. Okay, I took them fans out, went and grabbed 2 fans that were supposed to be green but more high dollar fans, and look, they're blue. By that time I was like, you know what, I don't think he'll mind, I'll just leave them in. I don't think he'll mind, man. But anyway, here's your supply. I think I already showed it. I can't remember. These clips are so far apart, I can't really remember what I've showed and not. But here's the back of it. Okay, this right here is where you're going to plug in your cord for your amperage. Okay, so it's going to plug from here to the main deck. Excuse the mess here. Oh boy. And then you'll be able to read that there. So, alright. Let's get the attenuator board put in there like I said earlier. We'll be back. I don't know what's wrong with her. I done put her off my lap 4 times in a row and she keeps jumping up here. So it's freezing cold out here, so I'm gonna try to finish this up with my little friend here hanging out. But anyway, all done, brother. Let's see if I can get some extra light on in here. Excuse me. Oh, there we go. That helps. Alright, man. There's your handmade 10 dB attenuator board. Like I told you on the phone there, just turn that radio all the way down and just slowly start creeping up, man. Just because this amp will do, you know, 3, 4, 5,000 watts, ever how much it's going to do on the top end there, that don't mean you have to run it at max. You need to monitor your heat, run it easy, and it'll last you forever, man. So I went ahead and tripled up on these resistors for power dissipation. We've got here a T attenuator. It worked out really well. Didn't even have to drill any new holes, because that hole that I had already drilled was in a perfect spot. So I actually got that right on the money. So alrighty, man, so just with a 10 dB attenuator, so you got to look at it like this right here. A 10 dB attenuator is taking your power, it is knocking it down 10 times. I believe I'm right about this without looking at my sheet. For example, if you were running 100 watts, okay, it would knock that 100 watts down to, you know what, I may be wrong. I'm wanting to say 10 watts, I believe it is. But it may be 1 watt. That's bad, ain't it? Especially during the video. 1 second. Alright, I was halfway right. I was right by the wattage, but not the time factor. So yeah, if it was a 10 dB attenuator, will knock 100 watts down to 10 watts. Yeah. 10 dB attenuator. So what we're rolling with is a maximum of 50 watt drive And if you do the math, you're basically going to roll with 50 times 0.1. That's going to put you right there about 5 watts, I believe. And that's more than enough for this. I wouldn't even get as close to 50 watts if I was you. But there again, that's another little controversy I'm not absolutely 100% sure on. We're talking about watts here, okay? Actual watts. My mentor in this area tells me that's more geared towards RMS wattage, okay? So that's a whole different ball game. Look, there's an attenuator on there. It's protecting you. Ease it up. Watch your amperage draw. With this particular unit, if it was mine, I wouldn't go any higher than 60, 70 amp draw. Yes, it can do up to 100 amp draw. Yes, it can. I'm just saying, if I was running every day, heck, if I was running every day, I'd probably keep it around 40, 50 amp draw, run at half throttle. But hey, that's me. I'm a little different now than I used to be, especially when it comes to high dollar equipment like this right here. I just look at power in a different manner. I look at it in a more of a logarithmic manner. But anyway, for anybody that may want to take a screenshot of this, my buddy Mr. RF Man wrote this up right here. Very valuable information. And that's another thing. This right here would not be possible. Absolutely not be possible without Mr. RF Man. I'm sure just about all of you know by now, he designs the boards. Very good job. Alright. I'm going to be trying out a new idea. I see that Mr. BBI has done as well. I'm going to try a dual amplifier using single boards. To me, I think that's going to work a lot better. Yeah, it's going to take up more space, but there's going to be less heat on the output transformers, because these output transformers can get hot. That's why you need this air flowing. I made sure to let these resistors off the heat sink so the air can flow up under the resistors and seep through them, just to make sure to keep them resistors cold as well. But alright, man, there again, I don't have I know you're going to be using this with a ham rig. I do not have a ham rig set up over here. I do have a ham rig back here behind me, but I am not unhooking it and bringing it over here. I'm sorry, I'm not. It stays over there. It's hooked up to millions of cables, and it's in operation. I am not moving it where it's at, but I do need to get me buy me a used ham rig just to mount up here somewhere, pretty much just for doing these, or get a good SSB radio that I can that basically I can control the output of that radio. I would like about 100 watts down to like maybe 10 watts. So I just want to basically show you that the attenuator is working. I can get in here and start hooking up some hot radios. Do forgive me, I wish I had some more. Like I said, I wish I had a ham rig on here so I could actually take that power that I'm talking about and start easing it up and show you the different outputs and everything, because that's the beautiful thing about a ham radio, is you've got that you've got a lot of control. You can take that thing and turn it down to almost, of course it matters about the radio, but I know on mine I can turn that thing down to like 5-10 watts and then all the way back up to 100. I mean, I've got a lot of control on that thing. We're talking about sideband, of course. On AM, it's 40 to 4 watts, I believe, something like that. But But you know, this is just the third amplifier right here. And as time goes on, I'm going to get more of a setup for LDMOS boxes and have more equipment so I can show it. Would you get down? It's like having a brick on my dang lap at all times. Alright, I got the supply turned on. Boy, them fans are something else. Alright. Let me take this 5K out real quick. We ain't gonna be hitting nowhere near 5K now. Alright, so I'm on the bench radio again. I have not even checked to see how much this is gonna be doing now. Alright, before we were getting, what was it, right there, about 3,500 watts, something like that. That was actually last night. I can't remember. It was something like that. Okay, so now basically you can look at it like this. I won't do the math in my head, but we're taking that 3 watts RMS, 2 watts RMS, 3 watts RMS, and we are now I can't even do the math in my head. I think, let's see, we're bumping it down to a very tiny input. Let's just put it alright. PEP on. And y'all forgive me, man. I am very tired right now. Let me turn that back off. Make sure we're getting output. Gold. I did check it, man, with the attenuator on. It looks like it even helped the input even more. Looks like the input has actually dropped, which of course you're going to see that because we've got an attenuator on there now. But if this attenuator was not tuned to 50 ohms, you would actually see more input reflect come in. So these things have to be parallel to ground at 50 ohms on both sides, as close as possible. I mean, you can actually use attenuators to do impedance matching. Alrighty. So let's see what this bad boy's doing with, I don't know, 0.1 of a watt, something very tiny. A very tiny drive. I'll do the math later. I should have done it beforehand. Go. Dang, man. This thing is doing over a kilowatt. Golly. Let's see what it's doing RMS. What was it doing last time? 600-700 with that little bit of drive. Oh, so we're right there about 200 watts RMS now. Oh, this thing, you could keep this thing keyed up like this probably all day long, and I doubt it'd even generate heat hardly. So that is cool. That is really cool. Let me take that 1K out. Boots just jumped back on my lap. If you don't watch it, you're gonna get burned over here by this RF. She just wants to stay right here and see what's going on. Just me and my cat. I am a dog person, but I love my cat too. Alright, I'm just kind of curious if it's doing a little bit more in the KW or what. Oh, yeah, about 1100. It's amazing. It's amazing. Absolutely no heat buildup whatsoever. Alright, man. I know that you are... Yeah, just go ahead and get off. Get off. I'm sorry. You're getting on my nerves just a little bit, baby. Got your preamp switch, SSB switch. This right here. See, I can't even remember. These videos have been so widespread away from each other. I don't even know if I went through here and described all the options that's on this amp or not. Oh, no ma'am. No ma'am. You You know better than that. You know that that's a humongous no. I'm sorry, y'all, but that's one thing I have taught her right very well. She does not jump up here on my bench. I don't know what in the world's going on with her. I swear that cat's bipolar sometimes. Sorry about that, y'all. That's very weird for her to be jumping up on my bench like that. There's times I used to let her up here, but I don't know more. I cannot believe that she did that. Back to what I was saying. Basically, we have a thermal switch. Okay, I got a thermal switch installed right here at the very corner of this heatsink. Reason being, the thermal switch circuit that I've put together is still a little bit more in the experimental stage. That is also one reason why I've got a switch back here, so you could turn that circuit off. It's on now. You can turn it off or on. Okay, and basically what that is if this thermal switch is mounted on the very end of this heatsink, gets 115 degrees Fahrenheit, meaning if the corner of this heatsink gets that hot, then you know the center is a lot more hot, or hotter. So if that gets 115 degrees, it is going to go ahead and throw, actually actuating this relay right here, which is actually going to be taking the 12 volt DC power away from the relay. Okay, so I've got it set up where it's just flowing through this relay's common coil to the normally closed common pole to the normally closed pole, and then it's just flowing to the relay. Okay, so as long as that thing's not 115 degrees, it's just going straight through there, even with this switch on and off. All this switch right here is doing is turning this power going to this relay on and off. Okay, so if it's turned off, then it's just flowing through this relay, DC power, and the circuit's not active at all. Alright, so, and if that does happen, power gets took away from this relay, this LED is going to light up. I can't even remember what color I made it now. It's probably red, blue, or something like that. And then once it cools down, it's going to go off. I've already tested it already with a torch, and I put that top back on there. Man, that thing cooled off pretty dang quick. As you can see, this thing is absolutely airtight down the back. These heat sinks could not have been a better match. Just in case you're wondering, these heat sinks actually come out of two 2x8 TNTs. These are two TNT heat sinks that a buddy of mine welded together for me. And if you see, I've got them down here on aluminum standoffs. Okay, and what that's doing is keeping them elevated to the point where it's not going to be bowing. Okay, because heat can make things extract, etc. And of course, I've got L brackets. When you do a custom amp like this, you're putting it in the box, and this box wasn't designed for this type of amp, you've got to get custom with things and figure out how you're going to do things. As you can see, the SOs are mounted directly to the heatsink for the ground. Just stuff like that, you know. So that's the way that is done. Let's see here. And I'm going to blow this thing out a little bit before I put the top on it. Just being out here, even though I am enclosed, just having the top off this thing the last few days, a little bit of dust got in here, but I'll get that blowed out. Alright, on with my rambling here. Of course, we got the preamp right here that you asked for. Not that big of a deal, just a regular old preamp. Got your keying circuit right here with the optocoupler. Alright, let me explain what this is right here. If you look at this right here, okay, we've got an RCA plug on the back here, and I can't remember if even I had a label for that or not. I think I do. I'm back here feeling, I ain't looked at the back of this amp in about a week or so. It's been right here on the bench. Why is this thing flashing 0.00? I'll be right back. I ain't never seen the camera flash this before. I want to make sure this thing is recording. Y'all hang in there with me. Alright, I think what that was telling me is I was running out of space. Basically, this is your external key, okay? Now, if you look on the back of your ham rig, you should have a key, or it could be named a lot of different things on different rigs. You're basically looking for the output on the back of the ham rig. You can use a continuity meter to actually test it out. Basically, whenever you key your microphone, that jack shorts the outside of the RCA plug to the center, or vice versa. That's all you want to do. And what that's going to do is it's going to take the ground, which is the actual case ground, and connect directly to this, the negative of the relay, and key the box. Okay. That's the best way to do it, especially when you're on SSB. If you're going, I know you're going to be talking a lot of SSB probably with this, and that's the best way of doing things, honestly, if you want to. Or you can use a foot pedal or a manual keyer, but that's what that's for. And yeah, I do remember I did get a label. There's a label on the back that says key. All right, of course that right there is your shunt. First shunt I bought, I'm telling you, man, this I'm just being truthful, I've made no profit with this box. I did not count the cost of the splitter and the combiner. Okay, I'll talk about this in a minute. That was 300 something bucks straight from Russia. I watched that video BBI did with that quad he did, and I think he actually mentioned these, if I remember correctly. And I know he's got his covered up on his box, but I'm just going to take a wild guess. I'm wondering if he's using the 4-port from Russia. But I will never buy these again, because I'm just going to build them from now on. I could build these for literally a quarter of the price that I paid for them. The only thing I do need to figure out is what ferrite they're using, or I just need to do a little bit of math and look at a couple of ferrites and just find one. It's going to be pretty much good for at least a range of 160, 1.5, 1.8 megahertz to 10 meters. Just for any guys, it's going to be, you want to make something that's going to work for everybody. That's what I'm trying to say. For whatever they use the amp for. These are wide banded amplifiers. When it gets to a user, they're going to do whatever they're going to do with it. You want to make sure it's going to be able to be done that way. Now, if I did a LC circuit or an L match type tuning, or shall I say combining / impedance transformation to combine the boards together and up the impedance back up, or vice versa on the input, that's going to be a super narrow deal right there. This right here is what you call wide banded. Okay, that's narrow. That's only going to work for a very slim frequency range. But I ain't trying to give a whole lesson or nothing right here, but basically what you have right here, for anybody that does care, okay, this is a splitter, and of course this can be used as a combiner or a splitter. Alright, what you have right here, this is actually a transformer, a 2-to-1 transformer, meaning the RF is actually coupled from the primary to the secondary of this transformer right here. And this ain't no secret secrets, man, this goes all the way back to ancient Motorola handbooks here, okay? This ain't nothing secret. And what this is doing is taking the input ZN coming from your relay, coming from your radio. It's taking that 50 ohm signal and it is splitting it up into two 50 ohm signals. Okay. Yeah. 150 ohm. I take that back. I'm so tired. It's taking the 50 ohm signal and it's upping it to a 100 ohm signal. Okay, it's 2 to 1. It's taking the 50, upping it to 100. Then it goes to this splitter right here and splits to two 50s. I believe that's how that goes. I don't know what's going on in my mind. What I was about to say is it's taking you 50. Look, if you don't look at it in a very simple way, it's taking your single 50 ohm signal and splitting it to two 50s. Okay? If you didn't have this transformer right here, what would happen is it would take that 50 ohm signal, and instead of having a 50 ohm signal on both inputs of each of these amplifier boards, you would have a 25 ohm signal impedance. I don't know why I'm saying signal. Y'all forgive me. I'm having a rough night. I didn't have much sleep at all last night. And then you would have a little bit of VSWR on the input. All your power would not be making it on the input. Same thing you have right here, you got right here. Alright. Now what these resistors are for, if something happened in the transistors, the MOSFETs failed on one of these boards, those resistors right there would take all of the punishment while the input will still be going into either a board that's still working properly without any added SWR on it. That will be soaking up the mismatch from the board that is not working correctly. Now, that can happen for the output as well. The only problem is I didn't get deep into that. They didn't offer the resistors with this. I just didn't go that route with it. I would have to figure out how I would pull that off with something of so high of wattage. But basically I would have to find resistors with an S, it ain't gonna be one resistor, that will equal up to 100 ohms. Okay, these right here are two 200s in parallel. That is, it doesn't have to be the amount of wattage to handle the full amount of output of the box. It just needs to be a certain amount of wattage the resistor does to be able to handle the mismatch of the amp that is inoperable. Alright, so, and then this doesn't have them on here. That's something I'm going to have to look into. This is the first one, y'all. This is the first of its kind on my end. But if they were on there, if one of these boards quit working, the other board would continue to work. This would soak up the input mismatch, and the resistor that would be on this would soak up the output mismatch, and the other board would be working just fine. Same thing if you had 4 of these boards and you had that set up. One went down, the other 3 would be working. 2 went down, the other 2 would be working. If 3 went down, the other would be working, and so on. This, if you want to look it up, Motorola handbook, hybrid coupling. That's all I'm going to say about that. I definitely have more and more and more to learn about that. But anyway, let's move on. There's your amperage meter. Like I said, I already had this box painted and did not get to drill a hole to put the amperage meter inside of here. And I could have fit it right here. Could have fit it right here. Let's see. Right about right there, I probably could have. So what we've done is you're just going to have a plug that's going to plug into the back over to your power supply, and the amperage meter is on your power supply. Now voltage, if you want to check your voltage, just use a multimeter. If you want to just check your voltage, or if later on you want to put a voltage meter in a plastic box, something like that, be no problem at all. Just hook it up to the power leads on your power supply. You know, of course, it would be absolute best to have it here so you can see the voltage drop, but you're not really going to deal with much voltage drop up that higher voltage up at 50 volts, if you ask me. But typically, you know, it's fun to be able to put voltage and amperage meters in the box, but you know, it is what it is. It still turned out good. It turned out great, actually. I'm very happy the way it turned out. As Lance knows, me and him both has been through hell getting this thing where it needs to be. He's been through hell with me. I know he's going to be so glad to actually get this finally, and I'm glad to be done with it. Hey, on to the next project, as we say. Of course, that's your variable for the fans. Now, the only thing about the fans, let me show you. Alright, if you look on the board right here, you'll see there's a blue, where's it at? Right there. There's a blue trimmer, okay? That is supposed to be able so you can trim this out so this right here will be linear. But what the issue is that there's so many fans on the circuit, it's just not working out. On the last one I did, I was able to make it pretty linear, but I think they could have improved that on the board, but you still can sit here and control the fans no problem. See, we're going to go right here to full high. It's already slowing down. Slowing down. So you're going to probably have a range about like here. So you're just going to be very easily hit it. Yeah, it doesn't have a big range on it. Once you get up about, let's see. So you can't even hardly hear the fans there. They are still pushing air. The sounds just pretty much went down to nothing. I'm just going to kind of slowly do this till they stop. Alright, they're still spinning. Alright, looks like you're pretty much going to have about a range of right there. 12 o'clock. Yeah. Looks like they're just getting a tad. Okay, yeah, they're turning off now. So that's what your range is going to be, right there about 12 o'clock, okay? Boy, them things are pushing some air. Good God almighty. I love putting AC fans on these, man, so you can control them like this. But hey, I'll tell you like this right here, run them as loud as you can stand. It's always best to have as much air as you possibly can have. Alright, man, well, I think that's about it for this box. I may come back before we get shipping out tomorrow. I may come back and hook up some more radios. I don't know. I'm trying to think. Because see, I had the same issue with the last one I did once I got the attenuator. Without the attenuator, about the only radio I can run is my bench radio. The radio bigger than that, no. It's gonna blow. No. These devices are absolutely awesome. Okay. But you just got to be careful with the input drive. Okay. You got to be careful with the input drive. They're not real good taking input drive, excessive input drive. Okay. They're almost indestructible on the output. I'm using the word almost. To a user, a regular user, they're indestructible on the output. When you're dealing with a mismatch. Once you start playing around with capacitors and stuff, shunting to ground the output, It's a no-no. That would be people that's actually building them and stuff like that, etc. So just, you know, that's why we got the attenuator on it. But now the attenuator's on it. It's pretty much set up for your radio now, which I don't have your radio here, and I don't have a radio here that does that amount of power. Okay, now, yeah, I could hook my hot radio up to it now, but let's see here. You know, I may have a radio I can hook up to it. Give me 1 second. Well, I guess my luck ran out tonight. I was going to hook it up to this Superstar because it does about 50 watts output. That's PEP though. I can't really control that. But, I mean, it's hooked up to the power supply and everything. I don't know why it's not coming on. But I ain't really worried about it, man. I think we did pretty good. I would have really absolutely loved to show you 6,000 watts, man. I advertise this thing, so many people are doing 6 kW. And I'm not saying it can't do it and everything, but I've just found out with the dual boards, I'm happy with about 2 to 2,200, 23, 2,400 watts with the boards. I'm not going to have super high expectations for them. But we still got a lot of learning to do with this stuff, man. This is not cheap equipment. You know, you just can't have 20, 30, 40 of them laying around doing some crazy tests. I can't afford it. So I'm just trying to take things slow and just go one at a time. Yeah, I know this ain't really considered slow, but Lance wanted to do it. I had already done a single, already done a dual, so we did a quad, which is 2 duals combined. But anyway, I appreciate y'all for hanging with me during all my rambling. I'll probably come back one more time with the top on and show you how it looks all put together. But right now, this thing's about to die. Thank you, Lance. I got to make your cord to hook from one unit to the other. We'll be back. Boy, ain't she beautiful. I wish she was mine. I ain't put screws in it yet. I'm gonna go hit the sack, do that in the morning, but I just wanted to put the top on them. Boy, there's some. Alright, well, it died on me that time. Got to show you the input reflect anyway. Camera died, by the way, my man. I watched, look. Dude. See what I mean by it lowered even more? I think it's doing a little bit, about a half a watt. So that, and I'm telling you, the way I put those resistors together, I mean, it was literally right there on the money of the value resistors I needed for a 10 dB T-style attenuator. Alright, brother. Well, I'm going to get these things wrapped up. Get that supply over there wrapped up. We got to figure out what we're going to do about power cable too. But I think you're going to have them close enough to each other. I'll send you enough to make you an eyelet and all that. I don't know if I'm gonna have enough time, but of course we got these Andersons on here. Okay, I'm gonna send you 2 of these. I should have enough wire to send a little bit to you. Put ring terminals on them, hook it up to the supply so you can hook both of them up to each other, and you can add order some longer wire if you need. I'm out of 8 gauge wire now. I've got to re-up on some of that. All right, man. Thanks for hanging in there, and I don't know when everybody will be able to watch this video, but when you do watch it, I hope you enjoyed it. Even with my mind about scattered as a star as is up in the sky, old Gatekeeper, out here around the northeast end of Georgia. I'm good and gone. Bye-bye. Thought I was gone, didn't you? I forgot to mention one thing. I can't remember if I showed you the back or not either, but here's the back. Of course, you got a lot of bolts and screws and stuff. But these are how real amplifiers look like, by the way, y'all. Real home brews. Holding all that stuff on the back walls. Alright, super important. Don't ever, and I repeat, do not ever unplug your amperage plug while the amplifier is turned on. Okay? I've made that mistake before, and guess what happened? Fireworks show, and it literally ate the tip of the plug off. I've got that somewhere, by the way. I kept it just so I could show it on camera, and I'll have to show it on another video. I've got it somewhere, but it literally incinerated pretty much the end tip of that phono plug, stereo plug. Always plug these in on both units with everything turned off. If you ever need to unplug them with it turned off. Okay? Yes, this should not be grounded against the case because it's painted, but it still could be, just to be safe. You don't want to unplug that thing and have that thing hit the case. There's no fuse on that. Just remember that, okay? Airtight, baby. Airtight. All that air flowing through there is coming directly through those fins. Now that's called forced air cooling. You gotta love it. Alright, buddy. By the way, this fuse right here, this is just a fuse for the 110 going to the fans. 110 going to the power supply for the 12 volt supply in there. You're pretty much good with 110 volt 5 amp fuse. If you ever have an issue and blow a fuse or whatever, you're good with pretty much a 5 amp fuse. You're good to go. Alright, bud, I do need to get more labels done. There's more of these that we put out, that I put out. This thing is beautiful, man. Still, the color don't do justice on camera. You got to see it in person in the daylight. When the sun hits this thing, it sparkles. And yes, Mr. Lance got this paint job free. I always take care of my customers. When I'm in the wrong and things take longer than expected, I always try to do something. And I had to do a little bit of something for Lance, because he has been hanging in here with me through this. This was a big research and development project. Thank you, Lance. Yeah, that came out of my pocket. That's what I mean. This is a no profit bill, but I gained some knowledge. It's hard to put a price on knowledge. It's time to hit the sack, y'all. Bye-bye.